everyone! In this video, we'll learn about 5 important topics in motion, which are distance, displacement, speed, velocity, and acceleration. This also includes some demonstrations in order to visualize them easier. Distance is the total length of the path traveled by an object without considering its direction. It's a scalar quantity, meaning it only has magnitude but no direction. In this demo, the blue trail represents the total distance traveled by the ball. Even if the ball changes direction, we just add up the length of its traveled paths. Here's how to solve a simple problem about calculating the total distance. An object moves 3 meters east, then 4 meters north, then 5 meters west. What is its total distance traveled? To solve this, we just have to add the lengths of all the traveled paths. So, 3 meters plus 4 meters plus 5 meters is equals to 12 meters. Therefore, the total distance is 12 meters. Displacement is the straight line change in position from the starting point to the current position. It's a vector quantity, so it has both magnitude and direction. Here, the red arrow shows the displacement, which is connected directly from where the ball started to where it is now, no matter how twisty the path is. It is also said that distance equals displacement if the object only travels in a straight line and does not change direction. As shown in the demo, once it starts changing direction, distance is now greater than displacement. Here's a simple problem. An object moves 3 meters east, then 4 meters west. What is its displacement? First, let's assign east as the positive direction, with west having the negative direction. So, therefore, the first movement is 3 meters towards east. Then, second movement is negative 4 meters since it points out in the west direction or the opposite direction. For one-dimensional motion, displacement is d is equal to x sub f minus x sub 0, where x sub 0 is the initial position or the starting point, and x sub f is the final position. So we start at x sub 0 or the initial position at 0 meters, since this is where it started. Then after moving 3 meters east, we make x equals positive 3 meters. Then moving 4 meters west, we subtract 4 meters. So positive 3 minus 4 is equal to negative 1. Therefore, our final position is now negative 1 meter and our initial position is now 0 meters. So our displacement is equal to final position minus initial position, which is equals to negative 1, the final position, minus 0, the initial position. Then our displacement is negative 1 meter. The negative sign means the displacement is 1 meter to the west. Speed tells us how fast something is moving without considering its direction. It's also a scalar quantity. In this demo, the evenly spaced dots show that the ball covers equal distances in equal times, which means that it has a constant speed. Slower speeds meant that the dots are closer to each other, and faster speeds meant that the dots are farther from each other. Here's a sample problem. If a car travels 100 meters in 5 seconds, what is its average speed? To solve this, we'll use the formula S is equal to d over t, where S is equal to speed, d is equal to distance, and t is equal to time. Plug the given values into the formula, and you'll get 20 meters per second. Velocity is speed with direction. It's a vector, which means we describe how fast and in what direction something moves. In this demo, the arrow shows the velocity vector. Its direction matches the motion of the ball, and its length represents the speed. Here, the speed is constant, but the arrow's direction changes as the ball moves back and forth. Here's a sample problem. A car moves at 120 meters north in 3 seconds. What is its velocity? To solve for this type of problem, we can use this formula V is equal to d over t, where V is equal to velocity, d is equal to displacement, and t is equal to time. Plug the given values into the formula, and the final answer is 40 meters per second north. The north part is important. Without it, we just have speed, not velocity. Acceleration is the rate of change of velocity over time. An object accelerates when its speed changes, its direction changes, or both. In this demonstration, we're only focusing on acceleration caused by a change in speed, while direction stays the same. The dots start close together and get farther apart, meaning the ball's speed is increasing. The arrow length goes to show that the velocity magnitude is increasing. If the arrow were shrinking instead, that would mean the object is slowing down. Here's a sample problem. A cyclist speeds up from 5 meters per second to 15 meters per second in 5 seconds. What is the acceleration? To solve this problem, we need to use the formula A is equal to v sub f minus v sub I all over t, where A is equal to acceleration in meters per second, v sub s is equal to final velocity in meters per second, v sub I is equal to initial velocity in meters per second, and t is equal to time in seconds. Our given values are this. Final velocity is 15 meters per second, initial velocity is 5 meters per second, and t or time is 5 seconds. Then, we're gonna plug each of these values into the formula. So A is 15 meters per second minus 5 meters per second all over 5. So 15 minus 5, we get 10. And we have to divide that by 5. Therefore, A is 2 meters per second. 2 meters per second squared. Therefore, the cyclist's acceleration is 2 meters per second squared. That means each second, the speed goes up by 2 meters per second. I hope this video gave you a basic start on the 5 important topics in motion: distance, displacement, speed, velocity, and acceleration. This is just the beginning. Physics can get a lot more detailed and complicated as you dive deeper. If you're curious to learn more about advanced concepts, there are a lot of great resources and experiments you can explore online. The most important thing is to keep asking questions and stay curious. If you enjoyed this video and want to support what I'm doing on this channel, please give it a like and don't forget to subscribe for more. Thanks for watching!